Welcome, and thank you for tuning in to this webinar of Extending Your VHF Range, which is proudly sponsored by Shakespeare Marine Electronics, who's the world's leading manufacturer of connectivity products such as antennas, accessories, cell boosters, and a full portfolio of marine-grade products. I'm Matt Stockwell, part of the product training team here at Shakespeare. And when we're talking antennas, especially VHF, we're talking safety. With the exception of life jackets, your VHF is the most important safety device on your boat, and also the most overlooked, especially the antenna. Your radio is only as good as the antenna attached to it. Kind of think of it like your speakers to your stereo. And so today I was thinking we take some time to talk about what to keep in mind when purchasing your next antenna, as well as tune into the end of the show for some exciting and valuable tech tips. If you guys want to follow along, the web address is up here in the top. This is also available on our website whenever you want to go to it. And I'd like to start off, before we actually go into the antenna selection, or one big portion kind of an antenna selection, is talking about dB and gain. And there's a myth that all you need is the highest dB or gain antenna on your boat and you're going to have the farthest range. And although higher dB or gain can get you farther range just through the type of signal. So the higher your gain goes, the more focused your signal is. So when you go from 3, you can see to 6 to 9, you can communicate farther. But what you're limited by is the type of boat you have. And that being said is because smaller boats are going to rock more. And when you have rock, if you have too high of a dB, as you can see illustrated here, you could miss communication with the boat you're trying to dock to, which is definitely something you don't want. So when it comes to the dB or the gain and busting the myth, the rule of thumb is for powerboats under 24 feet and sailboats. And sailboats are the exception to that rule because even if it's a larger sailboat, just by design and how they operate, they're going to be rocking a lot more. So you want to go with a 3 dB. And then for boats 23 feet or over, a 6 dB. And then for boats over 32 feet, you can go 9 dB and above. So after we've talked about the dB, we can go into the other factor, which is the height of your antenna or where you're going to install it on your boat. And this is fairly important, as you can see in this picture, because the Earth itself is curved. So there's a thing called line of sight to horizon. So you're limited to that horizon line because of the curvature of the Earth. So the higher your antenna is, the farther your line of sight is, because you will be able to see farther over the horizon. So as you can see here in this depiction, both of these boats can make communication with this one, though this one has a much higher antenna and is actually farther away. So if you switch these positions, this boat would obviously still be able to communicate, but this one would not, because it would be limited by the horizon of how far it could see over. So that's what we're talking about when we're talking about the height and things like that. And we also have built into the website a handy tool of a calculator, which can determine the range of your communication, because everyone always has that question. They get an antenna and they say, what's my range? How far can I communicate? And there's a lot of factors that actually go into that. One of which, as you can see, the length of your antenna, the height above water. But the most important thing, and the thing that most people don't take into effect or think about, is you need to know the same of who you're communicating with. So from vessel to vessel, your maximum distance of communication range is going to differ depending on the height of those antennas. So just to give an example, we're going to pull up a photo here of a standard sport fisher. So if we're looking for the height of our antenna, so this would be our antenna here from the base to the top. And typically, probably on this type of boat, this is going to be an 18-foot VHF. So we know the height of our antenna. Now we know our height above waterline. And when you're figuring that out, you're taking from the base of that antenna where it's mounted to the waterline. So we're going to say that is 25 feet. So coming back to our handy dandy calculator, we said our antenna height is 18 feet. We're saying that we are 25 feet above the water. Just for the sake of this experiment, we're going to say that the other antenna's length is, say, 3 feet, because we're talking to a sailboat, and they have a 3 dB stainless steel whip. And we're going to say that their mast is 50 feet tall. So as you can see, we have a combined communication range of 18, a little over 18 nautical miles, which is, that's pretty good. And when you want to break it down, so our line of sight to the horizon is 8 miles. Their line of sight to the horizon would be 10 miles. Obviously, you combine them together. That's your combined communication range. And the reason theirs is higher than ours, even though we have a much higher dB antenna than they do, is just based off how high it is. So 50 feet above the water compared to 25 feet above the water, you're going to get a farther range just because VHF communication is line of sight. So the higher you are, the higher you can see over the horizon. So now that we've figured out the type of dB that we need an antenna, as well as the height of the length of the antenna we need, as well as the where we're going to mount it and how high it's going to be, there's several other factors of what we can do here. And these are basically, as we're saying, drown out the noise. So what we have here is we have 3 factors that we actually have control over in the efficiency of our transmission system. And when I say efficiency, what can make your antenna more efficient than another antenna are the inner elements, your coax, and your connectors. And the reason your efficiency is so important is even though that you have, say, a line of sight communication range of 8 nautical miles, if you don't have an efficient enough system to actually reach 8 miles, you're not going to get to the 8 miles. So you have the potential to 8 miles, but based off the factors of your antenna itself are what will make it, the most efficient to actually reach the maximum possible range that you could. So as we discussed earlier, or just a few moments ago, the inner elements, and this is probably one of the most important parts of when you're talking about the efficiency of your antenna or what makes one antenna better than the other. And this is what's kind of I like to focus on, is because this is what you don't see. When you're in the dealership or you're online, typically if you're seeing a picture of it, you're just seeing a white stick. And it's really hard to tell the difference between, okay, they all look the same. How are you telling me one's better than the other when they look exactly alike? And that's why I think this illustrates very well of what is on the inside that you're not seeing. So when we're talking the element, what that is, that's the radiating element. That's what is creating your transmission pattern. That's what's sending the signal out there. So for a basic communication antenna like these two here on the right, you're typically going to have either a thin just piece of coax with a piece of brass probably taped to it, and or you may have a very thin piece of brass element that's solid throughout that antenna. So brass is a good radiating element, but the thicker you can make that radiating element, the more efficient your system's going to be, the higher clarity you're going to have, the better reception you're going to have. So when you move into a more higher end antenna, you're going to see a thicker element, probably brass, and or if you're going to move into a premium line, most of which would possibly have a silver-plated antenna. And the silver-plated element is the best, just because silver is it's a better conducting material than brass, and you're going to get that efficiency and performance out of your system. As you can also see in these higher-end antennas, they have these foam spacers, and what the foam spacers do is they prevent the element from rattling or vibrating inside that the shell of the antenna, which can also improve the efficiency of it. So once we've determined, okay, we're going to get this height antenna, I want these elements, this and that, another factor to take into place is the fitting, or what is known as the ferrule of your antenna. So again, if we come over to the basic communication antennas, we have typically either a nylon and or a chrome-plated ferrule. When you move into a higher quality antenna or a premium antenna, you're going to get stainless steel fittings. And the big thing to think about that is you want like materials. So typically most mounts, marine antenna mounts, are stainless steel. So if you want like materials, you probably maybe want to look into a stainless steel fitting. You also probably would not want to put a nylon fitting onto a stainless steel mount, just because if you want the best life out of your antenna, like I said, you want the like materials. You put the nylon on the stainless, there's a higher chance of it stripping, and or you break that ferrule at some point in time. Another thing I'd like to point out is that even though from this basic antenna to a higher end antenna, those ferrules or fittings look exactly the same, One is chrome plated and one is stainless steel. So that's really something you probably want to ask that dealer when you're in there and you're looking at an antenna. Hey, what is that fitting made out of? Is that chrome plated or is that actually stainless steel? Which will give you an idea of the quality of the antenna you're getting. One other thing to bring up is most antennas, at least all of Shakespeare's antennas, we have the standard 1-inch 14 threading on them, which is the standard threading. But you probably want to know what type of mount you have and or if that antenna has the 1-inch 14 threading to make sure you don't need an adapter or that antenna can actually fit your mount and vice versa. And then after we talk about the fittings and the elements and all of that, the third factor that we have control over is the coax or the cable of your connector itself. And that type of cable is actually fairly important. Some people are like, it's just coax, how can it matter? Well, it can. There's higher grades of coax for different antennas. So, like I said, when you're looking at a basic line, you're probably going to have, an RG58. More higher quality antenna, you can get RG8X. Or if you move into, a premium line antenna, a lot of premium line antennas allow you to select your own type of cabling because they don't actually have the cable attached. It's you can fit it right onto the antenna so you can select whatever kind you want. This diagram here is showing for a standard 20-foot run of coax from a 25-watt VHF radio with basically a perfect tuning on it for the Vswr. So as you can see, anytime you add coax to a system, you're going to get a little bit of but transmission loss. You're going to get some dB loss out of that, which can be called the cable loss. So as I said, for basic communication antennas, RG58 with 20-foot run, you're going to get a 1.12 dB loss so that your cable efficiency is only 77.3. And as you can see, as you move to higher quality coax, you get a lot more efficiency out of your cable, which means more efficiency out of your antenna. And one thing I'd like to bring up, so if you have a sailboat and or you have a large yacht, I would probably recommend getting a premium line antenna where you can actually select whatever type of coax you want and just have the fitting on the antenna. That way you could move into something like an RG213 or an LMR 400 for that long cable run, so you're going to have a more efficient system. So as we were discussing all the factors that make an antenna more efficient, which will allow you to get your maximum line of sight to the horizon range out of your antenna, we talked about the element type, we talked about the construction as far as foam spacers or even the thickness of the fiberglass shell, your radome, your fitting, and then again on premium antennas to where they can be removable, which has better or more functionality than just I can select whatever type of cable I want. If you live in an area where you winterize your boat, this is very easy to uninstall your antenna to where when you get it wrapped, you don't come out in the spring and find a broken antenna and have to replace it. It also is really nice if you're upgrading your antenna system and you don't want to rerun that coax. If you have one with a removable one, typically you can keep the existing coax in place, just add a connector and install your antenna. So again, all of this information can be found on our website of Shakespeare Marine. Again, the address is up here, which will take you to the antenna selector guide. And these are the factors that you should take into mind when you're selecting an antenna. So for those of you sailboaters out there, I can completely understand that there's a lack of real estate for electronics and antennas on your boat. So if you do have a VHF and an AAS system and you do not have the ability to have the 3 feet of separation at the top of your mast between them, which let's face it, probably a lot of you don't, the VHF antenna is the one you're going to want at the top of the mast. The reason for that is the VHF is the most critical. It's a vital communication. AAS is just a secondary unit to help aid you. So also with the VHF, it is line of sight, so the higher that antenna, the farther range you could potentially get. As far as the AAS goes, it's more just to see the boats that are close in around you right now to help aid in your navigation. And that's why you would want the most critical, the VHF on the top and the AAS somewhere underneath. So there's really only one right way to test out your antenna and radio, and that's by the use of a tester, similar to the Art 3 by Shakespeare. The great thing about this device is it allows you to check your entire antenna circuit, basically, from the radio all the way back to the antenna, all through your cabling and connectors and splitters. And the way this is going to work is you're going to hook it in line in between your antenna and your radio. It's going to allow you to check the wattage of your radio. It will also let you check what's called your VSWR. Now, VSWR is a way to classify or quantify the efficiency of your antenna. And what you're looking for is a VSWR of 2 or less. So if you're anything above 2, it's really time to start thinking about, hey, I may need to replace my antenna, and start thinking about some of those, earlier topics we talked about in efficiency and things like that. So if we've gone through and we've tested from the radio and we've got good wattage and our VSWR is looking good, the next thing you might want to do just to check the entire package is for your area, find your local CTO automated radio check. Go ahead and hail out to that. That way you can get your playback or your transmission back just to see how you are in your clarity. So this can be a huge annoyance, especially if you were just starting your boating day and you're doing all your checks and all you want to do is spend some day on the water, fishing, and now you have to deal with this. So it may not be as complex or troublesome as you think. First off, if it were me, I would call the manufacturer of my radio and just have them go through my settings and make sure something didn't get flipped, the kids weren't playing with it, whatever happened. Make sure all my settings are properly set the way that they should be set. Secondly, a great tech tip is if you look at the back of your radio, there should be a little grounding terminal. Make sure that that's actually hooked up into the grounding system of your boat. Some manufacturers of radios say, oh, it's not required. If it's not hooked up, hook it up, give it a try, hopefully that works. And third, probably the answer none of y'all want to hear, but if all of that checks out, you probably want to think about replacing your antenna. So this problem can also be fairly common. Your VHF works fine, you flip on some other electronic device and now you're getting bleed over. So first thing to do obviously is make sure that those two devices, if they're antennas or anything else electronic, are not close together. Make sure they've got at least probably 3 feet of separation. Now if you've checked that out, chances are, even though the devices are fairly far apart, their cabling is probably running through the same channel or conduit on your boat. So there's 2 ways really to correct this. First one would be, if you have the ability is to relocate the cables from either one of the devices to where they're not close together, so you're not going to get that interference. Secondly, if you do not have the ability to do that, just use what's called a snap-on ferrite, and then that's going to shield your cabling from getting the bleed over, and it should correct your problem. So this is a very much frequently asked question, and these are popular on the market. But when it comes to splitters, what I really like to recommend is that, if all possible, you use independent antennas. And the reason for that is anytime you add a splitter to basically your circuit and you're breaking it off, you're losing your efficiency back to your radio. So in order to keep it the most efficient system as possible, you really want to avoid using splitters and use independent antennas wherever you can. Now, worst case is I can't run 7 antennas off my boat. I know that's a little excessive, but I'm sure some of you have about that many. The worst case is what I would recommend is that if you're going to use a splitter, use it from your backup antenna, your secondary VHF, not your primary. That way you keep your primary the most efficient as possible, straight antenna to radio. Another thing when we're talking about splitters and this and that is VHF and AIS. Now, a lot of times people want to use splitters, but what they don't understand is when you're using a splitter on a VHF and AIS system, since VHF frequency and the AIS frequency are so close together, it's going to split that power right there. So you're going to have a lot of loss from running it through a splitter. And it's very much recommended when you're VHF and AIS to have independent antennas. So again, I'm Matt Stockwell with Shakespeare Marine, and we would like to thank you for tuning in today. We do appreciate it. I hope that you got some some knowledge and some insight about it, and you know a little bit more about your VHF and your antennas. And any other questions on that, we can be reached at the following number and website. So, happy boating.